What are we turning in for type? Like we're turning in the 4 packets, the 4 tests,
and your final,
and our final.
and your final, and then you're turning in FRQs A through D.
A through D.
The final I gave you.
Oh,
the actual final problems.
Okay.
I'm supposed to collect those. You're not supposed to have those.
I wrote all over them.
Let me tell you the real truth. I'm not even gonna look at your final just to make sure you have them. Okay. The only reason I want them back is because you're not allowed to have them.
Okay, so that.
So I gotta pretend like I care.
Packets and all
Right. I'm gonna look at your other packets. Why? Because that's where I'm worried about you might not have chosen to do any work, and that would bother me. If you didn't do any work on the final, hopefully I already got you for that. I get, it's just, that's one of those things, right?
And there's 4 practice packets, right?
There's 4 practice packets, and I'm also going to want your final, so there'll be 5 full tests, essentially, what you're getting.
Oh, yeah,
Plus the 4 free response packets, I want those.
Do you want the free response in the final as well, like all the free responses?
The free response packets.
But
I don't need the actual questions, no.
Right.
I do need the free response packets. And actually, I'm just looking at that for work, because that's not things I have to require to pick up. Okay, green 23. Green 23. All right, what's green 23? It says, let f be a function that is defined
plus your
f of x equals 2x plus e to the x. G of x is the negative 1, right? So what kind of problem is this? I have g of x land. Sorry, I have f of x land, I have g of x land. And they're inverses of each other. Whatever I have in one, it's going to be inversed x and y in the other. Agreed?
Yeah.
So for x and the point 0, 1 in the graph for f, so 0, 1's here, so this is going to be 1, 0. Agreed? Okay, and I want to find g prime of 1. Agreed?
Yeah.
Okay. To do that, I'm going to have to find what over in f land? Nope. I have to switch my x and y. That's what we always have to do, right? So if it's 1 here, I've got to use the other number that's in the y category over here, correct?
Yeah.
So I want f prime of 0. Does that make sense? Mm-hmm. Okay, so now I got to take the derivatives. So I know what the derivative of the function is. F of x equals 2x plus e to the x. So that's going to be, the derivative would be 2 plus e to the x. I'm going to plug in a 0. Get 2 plus e to the 0. What's e to the 0? 1. So this becomes 2 plus 1, or 3. So this is 3. So what is it over in inverse land? 1/3. Same game every time. Locate your point. Flip it when you go to the inverse. Solve for the derivative. Then flip it, coming back. By using the word flip twice, it doesn't mean the same type of flipping, does it? So I'm sorry about that. All right, Julia. Red 25. Red 25. Red 25. Baby. Red 25. It is x squared. Y minus 3x equals y to the 3rd minus 3. The point is negative 1, 2. And I want to find dy dx. Agreed? Yeah. So what am I going to do? Ooh, no. Oh, ah.
I don't know. That's why I asked.
The reason why I'm acting like that is because how hard would that be to do?
So
I just don't understand.
That would be super, super hard to do. So because it's super, super hard to do, we invented a whole other way to approach this problem called implicit differentiation. We're just going to take the derivative of both sides and forget about it. Right? We're not going to try to isolate.
I know how to do this.
You know how to do this? You sure?
Yeah.
All right. Well, that was easy.
She's actually a genius, but she just won't accept it. She doesn't know it yet.
She has confidence issue. That is in fact true. I don't know if I want to label ADB a genius because that's kind of like a bad moniker. It's when somebody becomes a quote genius and they become arrogant and stupid, and frankly, that's not a good thing.
That is not a good thing.
That's not a good thing. I much prefer hardworking and sharp and intuitive. I prefer those. Brian, you got something for me?
Alright.
We just recorded that little rant, so that's good. Put that on the other line.
Also recorded.
Mr. Resney's now making up stuff. Brian, got what you're good?
Yeah, I'm good.
You're good. All right. Back to Brandon.
23 on the right there.
23 red. 23 red. Spend some time on the red. 23 red. Ooh. 23 red. This looks like what your problem week should what your problem should have been. I don't know if it is.
Oh, that's exactly what it is.
Yep. 3, 3. Negative 3, 3. Nope, it's definitely not. Oh gosh, this one's awful. All right, this one I hate, but it's legit. They will ask this question. So it says the graph of an even function y equals f of x consists of 4 line segments as shown above. Which of the following statements about f is false? The limit as I approach 0 from the left and right is 0. Is that true? As I move towards this, am I approaching 0 from both sides?
Yeah.
And that limit is 0. That's fair. Moving on. What does that look like? What is that?
B.
B. That is the formal definition of the derivative, right? So does the derivative give me 0 coming from the left and right?
No.
No, that's be undefined, right? So B looks very much like the false statement. That's the right one? Okay. The next, yeah. That good then?
Yep.
Okay. We'll leave it there then. You look like you're fully satisfied. Moving forward. That'd be Ursula, green test. What do you got for me, Ursula? Which one? 77. Holy crud. 1, 2, skip a few. Ooh. What kind of problem is this?
Related rates.
Good. Okay, so it's green. So our strategy is already set up. We know the sphere volume of the sphere. How do I write this volume of the sphere is decreasing? In Mathenese?
Negative. Well, dV/dt.
dV/dt is negative 3, right? At the instant when the radius of the sphere is decreasing, how do I write that? dr/dt is equal to negative 0.25 centimeters per second. What's the radius of the sphere at this time? Do I have any equation that relates volume and radius?
V equals 4/3.
V equals 4/3 pi r cubed. Oftentimes they give you the answer, don't they, to that question? So what do I do?
Take the derivative.
Take the derivative of both sides. dV/dt is equal to 4/3 pi. How do we take the derivative of this mess?
What? 3 goes down. And then r squared dr/dt.
dRdt. They gave you dV/dt, that's negative 3. R is what I'm looking for. dRdt is negative 0.25. Solve for R. Good.
I have the exact same thing and then I solved it.
Uh-oh, maybe keep going then? That 3 cancels out with that 3. I've got negative 0.25 and 4. That's going to be negative 1. So we get negative pi r squared equals negative 3. So that becomes 3 over pi equals r squared. I'm going for the calculator. Wow, that doesn't look like any of those answers, but maybe it is. Let's keep going. So 3 divided by shift pi to the 0.5. 0.977. I got E.
Yeah, I don't know what I did. That's weird.
Okay.
Plug it in.
You're good?
Yeah.
All right.
Plug it in. Channel that. You should get
All right. And in the rotation now joins. Got a question for me, man?
Yeah.
All right.
So, can we do the red packet, the first response question?
The red first response.
Yeah.
And it looks something like.
Because I don't think.
Question number 1. It's a sewage one.
Oh yeah, me.
Sewage goes in, sewage goes out. Is that the question?
Yeah.
Treated sewage.
Wait, here.
Yes, sir.
Did we get that calculator on the area ones?
Not usually, because some doofus came up with a program to do it. It came completely with what's the shape, what's the two sides of the bottom, which side is it perpendicular to. You just type it all in, it spits out an answer. And they said that's enough. We can't do that anymore. And that's why they went from having 3 calculated responses to 2 free responses. They said they're going to move the area 1 to the second part of the test. Now, the first year, they just dropped it from the test altogether, which was rude. And then the second year, they put it in the calculator section. I'm like, wait a second. That's why they moved it. But after that, it's been now consistently falling in the second part of the test. After that, the 2 surprises there. All right. So we're doing red, free response, freaky, 1, right?
Yeah.
Okay, so I've got raw sewage entering a treatment plant. And that's, got a formula for that. That's E of T equals 850 plus 715 cosine of pi T squared over 9 in gallons per hour from the hours 0 to 4. Treated sewage is removed from the tank at a constant rate. So the removal, there's no removal formula, no removal rate is equal to what? 645 is the removal rate, not T, 645, because it's the rate. If I wanted to do an integral, I would get 645 T, which would be how fast it's being removed, right?
Wait, shouldn't we also make it negative?
It depends. I think it's probably negative because I think we're discussing sewage as being positive at the moment. I'm not really sure that works, but whatever.
Well, just because
Electrons are negative and sewage is positive. Let's keep going. A. How many gallons of sewage enter the treatment set tank between 0 and 4? Round your answer is whole gallons. So I'm going to figure out how many gallons? Integral, yeah. I'm going to integrate from 0 to 4, this ugly formula. On this problem, because it's question number 1, I'd have the calculator on my desk. I certainly wouldn't bother to do it by hand. More likely to make a mistake that way. DT. They got 3,981 gallons.
Yep.
Good so far?
That is enough.
What?
I got like 300.
Are you in radians?
I hope so. I'll do it again.
Do it again.
You're good.
You got 3,900 and by that. You got the whole equation in there, the 850 in there as well? That would looks like would be the difference between what you just said and what they got.
Yeah, I'm pretty sure.
Okay.
I'll try it again.
Try it again. Let's see if we can get the right answer. Okay, so B, it says, at what time is the amount of sewage in the treatment tank the greatest? To the nearest gallon, what is the maximum amount of sewage? And justify your answers. All right. So I want to know at what time I have the greatest amount of sewage. To find out what time I have the greatest amount of sewage, I'm going to have to what? That would be some really sloppy mathematics, what you're talking about there. No, we wouldn't do that. We would. How do I find maximums and minimums? Come on, man. Yeah, I want to find the maximum sewage, so I want to take the rate and set the rate equal to 0, right? And that would be a maximum or minimum. I look at this and go, but wait a second, I'm removing some. So my actual amount of sewage is going to be, do they use a special, they use total sewage for time, the rate. They use an S of T just for the record. So we got 850 minus 645, which would be 205.
Really?
Is that right? Yeah, that feels right. Plus 715 cosine of pi T squared over 9. And I want to know when the sewage rate is equal to 0. So in other words, when they're chucking it out as fast as I'm getting it in. So how do I find where that's 0?
You subtract 205
Or I have a calculator on my desk that one of the skills I'm supposed to be able to is to find the zeros, and you were talking about cosine of pi T squared over 9. Don't try this without a rope and a chain, because you're not going to be able to do 205 over 715. Arc cosine, then the pi and the T squared, you're going to lose it somewhere, right? So you throw in your calculator. They say that if you do that, you're going to get 2.309 and 3.559 are the two choices. Now, that's not the only place I need to check. When else do I need to check? I need to check the bound. I need to check